It's day 2 of 5-1, finding nth roots, radical, and rational expressions. So as a little warm-up, I want you to try these 3 different expressions and see if you can simplify them. You want to rewrite it. If you can't find an exact number, you're going to use your calculator, and I'm going to show you how to do that real quickly, and then we'll come back to this. Let's see. So the problem, here's a problem, for example. It says 19 to the 5 halves. So let's go back and look at our calculator here. So you would write in 19, and you just would use the caret as your exponent, and you would do 5. Notice how it's still in the exponent mode. So you just do 5 divided by 2. And you would get your answer, and you could round that then to whatever it says. Now, some calculators don't leave it in the exponent mode. So in which case, you would have to put that in parentheses, 5 divided by 2, and close your parentheses. And then you should get the same answer. But that's just a little shortcut to using those exponents. But remember, you need to know how to do it the other way too, in case maybe we don't want it in decimal. Maybe we want it in fraction, or we want to leave it in the radical form. So you need to know how to do it without a calculator. Let's go back to our PowerPoint here. And let's look at this. So go ahead and try these 3 different expressions. I put a negative sign in there just to see if you remember those. And if you don't, I'll come back and explain it to you. I weighted 32 to the 3/5. I remember that I can rewrite it as a power to a power, so it would look like this. I'd take 32 to the 1/5, which is the 5th root of 32, and then I could cube it. So the 5th root of 32 is 2, and I cube it and I get an 8. Now the negative is a little tricky. I don't know if you remember, but I first separated out, so I put the -2 as the second exponent. So the cubed root of 27 would give me 3, and the -2 means I flip it. So I change the sign and I flip it, make a reciprocal. So 1 over 3 squared would be 1 over 9. Now this is one where the calculator would give you 0.111111, but we might want it as an actual fraction, so you need to be careful with that. Now this one, I started to write it as the 4th root of 50, and I know that there is no exact number, because I don't know of anything multiplied by itself 4 times you get 50. So I went ahead and just plugged it into my calculator, and I got an approximate. Sometimes use the equal sign with a dot over it, and sometimes they use the squiggle for an approximate. So I would have to round that one, whatever it says to do. Now, you might have an application problem like this, and I don't know if you've ever heard of F1 or F2 tornadoes, but this is the equation that they use to rate it. I think it's kind of interesting that somebody came up with this equation. Like I said, there's a lot of smart people out there and computers and analysis of different situations. So they took the F rating of the tornado, and they said, well, if I take the cube root of the wind speed divided by 14.1, square that. Okay, you take the cube root of all that, and then you subtract 2. That would give me a number that I could round. Here's what it says. If your answer is greater than or equal to 1 and less than 2, it's an F1. So if it was somewhere, if this F is between 2 and 1, then it's an F1. The F2 would be, as you can guess, it'd be equal to 2 or less than 3, right? So it goes up like that. So it's not a linear function, right? A cube root is not a linear function at all. So it says, what is the I'm probably mispronouncing it, Fujita scale rating of a tornado with estimated wind speeds of 100 miles per hour. I already have the equation, and the miles per hour is my W because it says wind speed right here. I always underline the really important things, and it's the miles per hour. Make sure I got my units right. So I will just put the 100 into that equation. So the F would be the cubed root of 100 divided by 14.1, and I'd square that, and then I would subtract 2 from that. Well, I would definitely use a calculator for that, and I got about 3.69, and I subtracted 2 from it, and I got 1.69. So since this falls in between 1 and 2, it's an F1 tornado. It'd be an interesting one to graph and see what that graph would look like. I want you to try simplifying these two. Now you will have to use a calculator to do it. So go ahead and try it with your calculator. Make sure you've got remember that I can set that equal to 16 up arrow 3 divided by 4. And then make sure you just take the negative of that. So you want to make sure you know how to use your calculator to do these. You could have done this one actually without a calculator. I showed you this way. The important thing is that you remember to do what's inside the parentheses first and then take the negative of the opposite of it. So I did 2 to the third. I ended up with 2 to the third, and then I did the opposite of that. 4 times 2 is 8. Now this one with the 3.5, I just rewrote it to say, well, that would be 3.5 to the 4/5, right? Because this is the 5th root, and that would be the 1/5 to the 4th. So I put that in my calculator and got the 2.72. Now we're going to put variables under the radical, and I'm going to show you a little trick here. There's different ways to do it. I want to show you the kind of why we're doing it the way we're doing it. But if I can rewrite what's under here to a 5th power, then I can simplify it a lot easier, right? So if I know 32 is, sorry, my pen isn't writing exactly where I want it to. 32 is, I could do the little tree if I wanted to. Eight, and that's 2 times 4, and that's 2 times 2. So that's 2 to the 5th. And m to the 15th is the same thing as taking m to the 3rd 5 times itself. This might be the tricky part right here, figuring that out. Well, what could you do? You could write, I could just say how many groups of m to the 5ths do I have, right? If I did a tree, I could do m to the 5th, I could do m to the 5th, and m to the 5th. That gives me 3 of them, right? So that's one way to do it. So I'll show you the wrong way first. Okay, so if I'm taking the 5th root of all these things that are raised to the 5th, the 5th root of 2 to the 5th is itself 2, and the 5th root of m to the 3rd to the 5th is m to the 3rd. I could do it that way. Another thing you can do, this might seem a little more complicated, but if I just take m to the 15th and I go, okay, that's the same thing as the 5th root is the same thing as that, then I could just do 15 divided by 5 would give me m to the 3rd. And that works really nicely if your variable there, say it was m to the 17th, and you take that to the 5th, well, you're going to get m to the 3rd, right? But you're still going to have 2 of them left you're going to get a remainder of 2/5. So you would do that. So 17 divided by 5 is 3 2/5 remainder. So the 2/5 looks like squared and 5. I'll rewrite that a little cleaner. That's another way to do it. Let's look at this expression. X to the 20th, y to the 8th. I could rewrite each of those like I did over here. Let's see, that would go in there 5 times. But another thing, a little shortcut, is just to divide those out and do 20 divided by 4 is x to the 5th, and 8 divided by 4 is 2. It's y squared. I just find that's a little bit easier than rewriting everything else. Now, something you have to think about here, if you're being really, really particular, is this could give us a negative number, so we would have to do the absolute value of that. This will always give us a positive number because this is even. This would be an absolute value. We're not going to go into a whole lot of great detail with that, but just to be aware of the possibility. I can't have a negative x, in other words. It needs to be positive, or I have to take the positive of it to make sure it's always x to the 5th is positive. If you had a negative x, you'd have to take the absolute value of it, in other words. I want you to try these two. I'm going to give you a little help here. I would say you could separate these out a little bit. You could do the cubed root of -8. You could do the cubed root of a, and you could do the cubed root of b to the 9th, 8 to the third. That would be one way to start it. The little division trick I showed you works really well too. The cubed root, and I took the cubed root of a -8, and you remember that when you have a cubed root function, it looks something like this. So the cubed root, to have a negative value down here, this one has to be negative. Kind of helps you. And then the cubed root of a cubed is obviously a, and this could be rewritten as b to the third, or I can just divide 9 divided by 3. Now remember, divide, don't subtract, divide, because it would be the same thing as this, and that could be simplified to be b to the third. Over here, I rewrote it, so underneath, I put 4 to the 4th and x to the 3rd to the 4th, right? Or you could say x to the 12/4. You could do that too if you wanted it that way. Here's another way to do it. So remember your index there. You could have written that as x to the 12/4 and y to the 24/4. And notice, either way, it's the same thing. So I simplify that and get the 6, and simplify the 12 divided by 4 and get the 3, and then it's a positive. Now, if we're going to be really particular here, the 4th root always has to be positive. So if I have an even number exponent, it will be positive. But if an odd number exponent, I need to make sure that that is the absolute value of that. That's being just extra particular. Here's something that's kind of interesting, and it's not really any harder than what you've already been doing. So if I have 2x to the 5th equals 64, I need the x by itself on one side of the equation, so I divide both by 2, and then I get x to the 5th equals 32. Now, that means that I could take the 5th root of both sides, right? I could raise this to the 1/5 power and raise this to the 1/5 power, because 5 times 1/5 is 1, and that would be 32 to the 1/5. So you could put that in your calculator, and you would come up with the answer of 2. Or you might know in your head that that's the same thing as this, and you might know that if I factored it out a whole bunch of times, like I've done before, I would get 5 2s. 1, 2, 3, 4, 5. So 2 times 2 is 2 is 5 times. So that's 2 to the 5th underneath. I take the 5th root of anything to the 5th. It's that thing, right? So the 5th root of 2 to the 5th is 2. I want you to try these two, doing the same thing, and I just want the real solutions. Okay, stop it and come back. Divided by 5, so then I ended up with this, which you could just go from there and go, well, that's 64 to the 1/3. And that would give me 4. You could do that in your calculator, or I did the other steps here if you wanted to look at those. Now, since this is an odd power, I need an odd number of real solutions. So I only have one. I remember that the graph looks something like this. And so 64 might be here for the y, and the x would be right here at 4. So it only has one real solution. Now, when I look at this one, I simplified it and divided by 2. I got p to the 4th equals 81. So that would be like 81 to the 1/4. You could put that in your calculator just like that. Or you could do what I did here. Now, your calculator is just going to give you the 3. But it's asking for the real solutions. And this is an even power. I remember the graph would look something like this, right? So 3 here would give me an 81 here. But it has it's even, so it has the negative 381 over here. So I know that this would have to have 2 real roots. Here's the concept that you would need to understand when you're trying to solve an equation such as, I'm trying to solve an equation such as x cubed equals 64. This is telling me that I can raise each one to the 1 over nth power, which is 1 over 3. And I could put that in my calculator, and I would get x would be 4. And since this is an odd power, I only have one real solution. Here's an interesting application problem. You have this cool looking fountain here, and I have a cube-shaped container, has an edge length 2 centimeters longer than the edge length of the second cube. Oh my goodness. Okay, so 2 centimeters longer. And this is my top one right here, because that's the bigger one. Then the edge length, which I don't know, so I'll just call it x, of the second cube. Anytime I don't know it, I just call it x. The volume of the larger cube is 729 centimeters cubed. Oh, well, that's handy. Okay, we know how much that one is. So when the larger cube empties into the smaller cube, how much water will spill? Well, I remember that the volume of a cube is s cubed. So this side I said was x, and this one, my side here is x, and this side is x plus 2, because it's a little big. So x plus 2 cubed is 729 centimeters cubed. How would I solve for x? Well, I could just take the cubed root of both sides. And then x plus 2, I'd probably put in my calculator 729 to the 1/3. And that would give me, now, probably you don't know that off the top of your head. Not a lot of people do, but that would give me 7. So 729 to the 1/3 is 7. So 7 times 7 is 49, and 49. Oh, wait a minute, that's not right, is it? No, I think I did something wrong. I'm going to double check that one. Hold on. That's a good way to, you know what, teachers make mistakes. You do things fast sometimes, just like students, right? We're human. Okay. So this right here, it should be 9. That's what it should be. I knew this wasn't right. So 9 times 9 is 81, and 81 times 9 would give you 729. Now I subtract 2 from both sides. There's where my 7 came from. X is 7. Now does it ask what X is? No, it says how much water will spill. So I could find the volume. I know this one's 729. I could find the volume of this one, which would be, the volume of this one would be 7 cubed. Now 7 cubed, you might want to do that in your calculator. 7 to the third is 343 cubic centimeters. Okay, so now I have some more information, and I do like writing on my pictures. It helps me understand what's going on a little bit. So I've got 729 centimeters cubed pouring into a 343 centimeters cubed. So to find how much is spilling, I would just subtract those two. 729 minus 343, and you should get 386 centimeters cubed. This is how much is getting spilled each time. And that could be useful because you need to know how big of a container you want and how fast the water has to pump and all that stuff. You wouldn't want it going everywhere. Here's one for you to try, and it's similar to the one we just did. I gave you some steps to follow. So try that one and come back and let's see how we're doing. Pictures, because pictures always help me. And I drew 2 cubes and one smaller than the other one. And in fact, it said it was 3 centimeters smaller. So I called this one X and this one X minus 3. I set up everything I knew. I wrote it down. What I wanted to know, I wrote here. Well, I know that the volume is X minus 3 multiplied by itself 3 times. So then I took the cubed root of both sides, found that X minus 3 would be 5.83, and add 3 to both sides, and X is 8.83. It didn't want X, it wanted the volume of the bigger one. So I put X into the equation right here, the side cubed, and then I ended up with 692.69 centimeters cubed for the volume of the bigger one. And that makes sense. I mean, if I think about it a little bit, it has to be bigger. If I got a number smaller than 200, then I knew I did something wrong. So this was our essential question, how we can use these exponents and radicals to represent roots of real numbers. And this is a good final concept summary. You might want to write these down. It has some general explanations, and then it has some specific examples. And these are always good to use. You can always look back, and we did some of these through the lesson, but it's important that you understand all of these concepts. Notice the radical form has the radical first, exponential form has the exponent first. So there's your exponent, there's your radical. And they're showing how you can go between the two. So this is radical to exponential form. This is exponential form to radical form. This you can put into your calculator. This you could put into your calculator too. And there's some other things there too, just some general algebra rules. You've learned all these learning targets. If you've practiced these, remember to practice, 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 and use your helps. Use your support, and the practice will help you get better and better at this. These are your vocabulary words that you should know. I'm going to give you an example really quickly. If I did 2 to the 5th equals, so you go 2 times 2 times 2 times 2, right? 5 times equals 32. Then I could say the 5th root of 32 is 2. Exponent, I'm just giving an example, would be 5. And the index, exponent on this one is 5. Index on this one is 5. The nth root is 2. So this would be the fifth root. N is 5, right? Fifth root. The radical symbol is this thing right here, and the radicand is the 32. Whatever's underneath the radical. So those are important words that you need to know. That's the end of today's. Thank you so much for listening and practicing, and try the Math Excel 5.1 Day 2, or B in my case, 5.1B.